So this is a section that's titled Trig Integration, and it covers a lot of techniques. In fact, in most books, you will find that this is broken up into more than one section. Now, a lot of it, in fact, most of it, I'm going to claim that you already know, you just haven't seen in the context that we're going to talk about. In other words, we're not going to use any new integration techniques. Essentially, it's going to be U substitution, and then we're going to need some trig identities sometimes to be able to complete things. So let's get started. We're going to look at a few examples. So the first example I'm going to look at is this: sine x, cosine x. Okay? In particular, I want to talk about powers of sine and cosine. As it turns out, if you have to integrate a product of powers of sine and cosine, the key is whether or not you have an odd or even power of one of them. So in particular here, this is sine to the 1 and this is cosine to the 1, so they're both odd. How do you do this? Well, I claim one way you can do it is you let u be sine x. Then du is cosine x dx. And if you'll notice, that's exactly what we've got here, cosine x dx. So this integral becomes the integral of u du, which you know is u squared divided by 2, add c, or sine squared x divided by 2 plus c, and there you have it. Nothing could be simpler, right? Well, let's do it another way. So I start out with the integral again, sine x, cosine x dx. Only this time I'm going to let u be cosine x. Well, if u is cosine x, then du is minus sine x dx, right? So if you want to write things out, dx is minus 1 over sine x du. And if I fill everything in, I get the integral of sine x, it's still there, cosine x, which is u, and then dx, which is minus 1 over sine x du. Now you will notice that my sine x's cancel, and I get a negative on the outside. The integral of u, which is cosine the integral of u du. Right? Everything else cancels, minus kicks out, which you'll recognize again is what? Minus u squared divided by 2 plus c. What was u? U is cosine x minus cosine squared x divided by 2, add c. So it seems like I did everything right. Now my question is, which of these two answers is right? Because they're different. Do I claim that those two functions are the same? The answer is absolutely not. They're not the same. Graph them. Then how can I possibly get two different answers for the same integral. Did I do something wrong? I claim no, I didn't do something wrong. So if both of these answers are right, then they have to vary by just a constant. The only difference is the arbitrary constant. Now, how can I see that? Namely, how can I see that sine squared x over 2 is just a constant away from minus cosine squared x over 2? Let's move things down even a little more. Seems like I needed more space than I thought I had. And let's finish this up. So how is this function a constant away from that? And the answer is, what do I know? Well, I know the trig identity, what? Sine squared x plus cosine squared x equals 1. That's one of the Pythagorean identities. Sine squared x then is minus cosine squared x plus 1, or sine squared x divided by 2 is minus cosine squared x divided by 2. Add 1. And the point is, sine squared x is the same as minus cosine squared x at a constant. So sure enough, those two functions are different by a constant, and hence these two answers are the same because of this addition of the arbitrary constant. Now the moral of this story is you can decide to do trig integration several different ways, and when you do, you might come up with two entirely different answers. But they can be reconciled by some obscure trig identity. In this case, the trig identity is not too obscure. All right, now let's look at a different problem. Sine cubed x cosine x dx. This is going to be a u substitution as well, and do you remember what I say? U substitution, key in on where the function composition is happening, and I claim function composition is happening here, and so the natural thing to do would be to let u equal sine x. Then du is cosine x dx, and you will notice that cosine x dx is exactly what I have here. So this integral becomes the integral of u cubed du, which of course is what? U to the fourth divided by 4, add c, and of course that cleans up to be sine to the fourth x divided by 4, add c, and there we've done that one. Now let's look at number 3 for a second. Now I claim 3 you should already be able to tell me what the answer is. What is it? Give me a function whose derivative is secant squared x. That's what this problem is asking. And the point is, what? I know a function whose derivative is secant squared x, and it is what? Tangent. So I'm not going to work too hard for that. Right? Because I know a function whose derivative is secant squared. All right. Now let's look at a different problem. Powers of tangent. And right now you ought to be getting a sense of what's going on here, right? You just have to be able to write things in a certain way to be able to use U substitution. Now, tangent squared, I cannot do, but the curious, as is anyway, but the curious thing is, I have a relationship between secant squared and tangent squared. In other words, I have a trig identity that fits. What is it? Well, you will remember, or you should go back and review that what? Cosine squared x plus sine squared x is 1, right? Now, if I divide by cosine squared, x, what do I get? 1 plus, now I get what? Sine squared over cosine squared. That is tangent squared x is 1 over cosine squared x, which is secant squared x. That is another, that's one of the 3 Pythagorean identities. By the way, I could take the top one and divide by sine squared x, and I get cotangent squared x. Again, I'm dividing this top one by sine squared. Cotangent squared x, add 1 is equal to cosecant squared x. So remind yourself of those 3 Pythagorean identities, and in this case, I'm going to use one of them. What am I going to do? I'm going to write tangent squared as the integral of what? Secant squared x subtract 1. I'm using the second one here. How does that help me? It helps me because you see, I just have to integrate secant squared, and I know what that is. So what do I get? It is tangent of x minus x plus c. And the point is, now I've used, by using one of the 3 Pythagorean identities, I've been able to do this problem. Now let's look at another one. Well, that one you should have been able to do when you walked in here, because you know a function whose derivative is secant tangent. Right? What is it? If you said secant x, you're right, and in which case the integral of secant x tangent x is just secant x plus c.